Okay, this question is from 2011 October November series. Paper code is 9702, variant 22, question number 5. And the question is based on Kirchhoff's law, which is actually the idea how to solve a circuit. So you have a potential divider circuit that is used as a means of comparing potential differences. Is shown in figure 5.1. You can see in the circuit diagram. A cell of EMF E1 and an internal resistance R1 is connected in series with an external resistor R1 and a uniform metal wire of total resistance R2. So due to the uniform metal wire is from B to F, you can see the connections. A second cell is also connected with an internal resistance R2 in series with a sensitive ammeter and is then connected across the wire at BJ. The connection at J is halfway along the wire. The current directions are shown right now using Kirchhoff's law to obtain the relationship between I1, I2 and I3. Now for the first part, if we are looking for, so we need to first of all, since applying a Kirchhoff's law and the relationship he is asking for is only about the currents, so it means we are looking for Kirchhoff's first law. For Kirchhoff's first law, we have to consider a node point. Let's say a node at B. So I1 is coming towards B. I1 is coming towards B. I3 is also coming towards B. Only I2 is going or leaving B. So you should remember the Kirchhoff's first law. The total current flowing into the junction must equal to the total current flowing out of the same junction. So I1 and I3, since are coming towards B, so they must, the sum of the I1 and I3 must equals to I2. Now for the second part, that's for the 1 mark. Now for the second part, you have a loop provided from H till H, HBJ, FGH, and you have to write an equation, right? So now since it's containing resistance, current and EMF and a loop is mentioned, so obviously that is going towards the idea of Kirchhoff's second law. For a provided loop, total sum of EMF must equal to the total sum of products of IRs. So now if we are looking at the loop provided, only battery E1 is connected in this loop. So first of all, E1 must equal to, now what are the products of IRs? Remember, for finding the products of IR, you must keep this in mind. The current must exclusively flow through a resistor. So if we see the direction of I1 is flowing from R1, I1 is also flowing from capital R1, right? There is another current I2, but I2 is traveling between B and J because there is a junction here. So I2 is probably flowing half of R2 because B to F is a full resistance is R2. So and J is already in the midway is mentioned in the question. So it means I2 is only flowing for half of B of a wire, metal wire, which is B to J, and the remaining portion of the wire must have the current I1. Because if you just imagine for a time being, if you just ignore this portion only, then I1 is flowing from here. I1 is flowing from here. Okay. So it means I1 is also flowing to J2F, which is again a half of R2. So if I start writing an equation, that is going to be, in fact, I1 R1 plus I1 capital R1 plus I1 R2 by 2 and plus I2 R2 by 2 I2. So that's for 1 mark. Now in the second loop, in the third part of this question, the loop is extended from direction B, H, B, C, D, J, F. So it means they are ignoring this path. they are ignoring this path. So it means you also have to ignore this path right now. B to J का path आप ignore कर दीजिए. Now the rest of the things are same except that in this path we have two batteries. Look at the polarity of the batteries. E1 positive terminal, if I am just looking at the polarity, the positive terminal, the positive terminal and the positive terminal E2 both are in the same direction. So I must write E1 minus E2 equals to, now I1 would remain same. I1 would remain same as like the previous case. So it will be I1 R1 plus I1 capital R1 plus I1 R2 by 2, except that there is another current I3 in an opposite direction to I1. Reason I1 is flowing like this, it's coming in the opposite direction to that, because if we look for the direction of the loop travels like this. The loop travels like this and I3 is flowing in an opposite direction. So I must take minus I3 and the only resistor is small r2, minus r3 small r2. That's the third part. Now finally they said the junction at J is moved along the wire. Explain why the reading on the ammeter changes. In fact, previously there was nothing mentioned about the reading on the ammeter. They just said it is connected in series if you look at the question. But that was also not about finding the E2 or E1 whatever. So like if the connection at the J is either here and goes over here, what gonna be happen to the ammeter reading? The ammeter reading will change. Reason, as long as J move along the wire, the PD across BJ will be changed, and hence resistance of BJ will be affected too. Therefore, this difference in PD will cause a change in ammeter reading. Alright, so this is how we're gonna solve this particular question from 2011 October November series paper 22. Thank you.